Hi, my name is Aliwarga, and today I'll be presenting to you the progress for my report. Firstly, I'd like to explain the background and aim of this research. Considering the importance of offshore pipes and how they carry essential electricity, cables, gases, and other forms of energy, this report was done with improving the design of offshore pipes in mind, exploring the different factors that are relevant to it. To do so, using ANSYS, a half-meter long, simple solid rigid body pipe model with a nominal diameter of 75 millimeters and thickness of 4 millimeters was modeled along with a ball-shaped impactor with a diameter of 30 millimeters, made of 316 grade stainless steel. Then, explicit dynamics will be used to simulate a low-velocity impact between the two models, where the impactor will be hitting the pipe at a velocity of 15 meters per second. The model will be meshed with linear elements, and a local mesh refinement on the pipe at the point of contact will be done for a better result at that point of interest. For boundary conditions, the ends of the pipes will be fixed with a fixed support, and the impact will also be frictionless, although these boundary conditions will be changed for some of the simulations. But overall, the other simulations will follow these boundary conditions. Also, considering the simple geometries that this analysis consists of, two symmetries will be applied onto the model, one on the XY plane and one on the YZ plane, to simplify the analysis by cutting the models into quarters and drastically cut down the computational time and costs for each analysis. This is essential as this research will consist of different analyses for different changes in variables, meaning there will be more than one simulations. To be able to make the analysis as simple as possible, some assumptions were taken, such as the pipe having uniform density, being smooth, and having no cracks throughout. Considering this is a simulation for offshore pipes, normally there would be effects from hydrostatic pressure and hydrodynamics. However, the simulation will not be taking those factors into account, as a report by Christopherson that will be referenced in the report also takes this assumption for his analysis and yielded relatively accurate results. Other assumptions for that were taken are that the test is conducted in standard pressure and temperature conditions, no thermal expansion will occur, and air resistance will be negligible. Next are the results. Here are some figures from the report showing what to expect in these results. The analysis consists of testing the setup mentioned beforehand and with some variables being changed, those being changing the solid elements into shell elements, changing the nature of the impactor to be deformable as compared to rigid, changing the shape of the impactor, increasing the drop velocity, including inertia in the initial velocity, changing the thickness and radius of the pipe, adding friction to the impact, and changing the supports to be simply supported. From the analysis, these are the results that were taken: the maximum deformation, stresses, and strains, as they will act as the main indicators of how the pipe behaves after impact, basically how it bends, and how the forces are distributed throughout the body of the pipe. These results will show what factors are important to be considered to improve the design of offshore pipes. Can be seen here, changing the thickness of the pipe has the most profound effect out of them all, having the lowest deformation level. However, this is not accurate yet, as there are other factors that need to be considered that might be more important than pipe thickness. This research, however, still has its limitations as mentioned before. The mesh convergence verification could be more focused and improved, and more iterations of it will most likely be needed to gauge out better, more accurate results. Next, a model that has a physical form of the supports will most likely be needed to reflect real-life models much more closer. And finally, the variable changes in the report has only been one-sided. Basically, it was only increased or decreased. Hence, the other part needs to be considered for the final report to better understand what affects those variable changes. That is all for my presentation. Thank you very much.